In this video, we're going to look at solving exponential equations without logarithms. So what we're going to be doing is we're going to be looking at equations that are what we call exponential equations. And exponential equations, typically, this is going to be a lead into exponential functions, is you have a variable as an exponent. So the exponent is what's changing. That's the variation. You don't have a variable as a base. You actually have it as an exponent. So let's look at some of the steps we're going to follow here. So let's look at the first example. I've got 2 to the x equals 8. Now what's important when you're solving an exponential equation is that you find like bases. And right now I have two bases. I have 2 and I have 8. So I want to make sure that these two bases are the same. Well, I can't make a 2 into an 8, but I can make an 8 into a 2, meaning I can rewrite this 8 in a form such that 2 is the base. So I'm going to bring the 2x down, and then I'm going to convert the 8 into an exponential form. So we know that we're looking for a base of 2, and 8 is actually a multiple of 2, so 8 is actually 2 to the third power. So we're going to rewrite 8 as 2 to the third power. Now once we've done that, we're going to actually look at the exponents. I know that 2 to the x is going to equal 2 to the third. That means that since the two bases are equal, and that's all we have, that the two exponents must be equal. Therefore, x must equal 3. So that is going to be your final answer. We don't have to do any extra calculations here. X is equal to 3. And that makes sense because 2 to the third power equals 8. If you were to plug that back in, you have 2 to the third power. You would, in fact, get 8. So that works. So let's look at number 2. Number 2, again, we don't have matching bases. I have a 3 and I have 243. My exponent this time is 4x. Doesn't matter what your exponent is. We're going to follow the same process every time. So I'm going to bring the 4x down. And now I'm going to try to convert 243 into having a base of 3. So we know 3 times 3 is 9. That's 3 squared. Times 3 more would be 27, that's 3 to the third. Times 3 more is 81, that's 3 to the fourth. Times 3 more would be 243, that's 3 to the fifth power. So what I've done here is I've matched up my bases. So once again, I have the same base, 3 and 3. Since 3 to the 4x equals 3 to the fifth, that means that 4x must be equal to 5. So I'm going to set 4x equal to 5. And this one's going to require an additional step from the first one. And I'm going to go ahead and solve this one. I'm going to divide both sides by 4, just like a regular algebra equation. And that leaves me with x equals 5/4. And that is your answer. Again, if you were to plug this in, 3 to the 4, and you plugged in 5/4 for x, 3 to the 4 times 5/4 equals 243. Remember, a power, these two powers are multiplied together. So 4 times 5/4, that's the same thing as 4 over 1 times 5 over 4. That would reduce, that would give us 3 to the fifth power, which is, in fact, 243. Now, I'm not going to check all of these, but that's just a way that you can figure it out. So let's do the next one. Okay, so we're going to move on to the next example. Let's go to example 3. Example 3, we have 6 to the 2x equals 1. Now this one's kind of tricky because you see the 1 and you think, well, there's nothing I can do with that 1. Actually, there is. You're trying to create like bases. 6 to the 2x, we really can't do anything more than that. So the question is, the puzzle is, how do we get a 1 using a base of 6? Well, if you remember your rules of exponents, your laws of exponents, anything to the 0 power is 1. 25 to the 0 power is 1. X to the 0 power is 1. So what I'm going to do is I'm going to change the 1 to have the base I'm desiring, which in this case is 6. So now I have 6 and 6 for my bases. So 2x is going to equal 0. So I'm going to set it up. I know 2x and 0 must be equal. So I'm going to go ahead and solve that. I'm going to divide both sides by 2. So x equals 0, because 0 divided by anything is 0. Now on to number 4. So let's look at number 4. On number 4, we have 8 to the 2x and we have 16. Now there's a unique thing about number 4. I can't put 8 to any power to get 16, and I can't put 16 to any power to get 8. So I'm going to actually have to find a common base and change both of them. Unlike the previous 3, where we only changed one of the two sides of the equation, I'm going to have to change both. In this case, with 8 and 16, it's 2. 8, as you know, is 2 to the 3rd. So I'm going to put the 2 to the 3rd there instead of 8, and that's still to the 2x power. 16 is 2 to the 4th. So now I'm going to multiply these out, because a power raised to a power, you multiply 3 times 2x, so that's going to be 2 to the 6x equals 2 to the 4th. Once again, I've put myself in a situation where I have matching bases. So that means that my exponents have to match. So 6x is equal to 4. And to solve it, we're going to use our last step. I'm going to divide both sides by 6. And x is going to equal 4 over 6, which is actually reduced to 2/3. So let's look at the very last one. This is the one that a lot of people have questions on. I have 1/8 times 2 to the x equals 32. This 1/8 is something that confuses a lot of people. So what I'm going to do is I'm going to change the 8. I'm going to leave the fraction as it is, but we know that 8 is 2 to the 3rd power. I'm also going to change the 32 since we've worked with it. 32 is 2 to the 5th power. We're familiar with that. So the question is, what do I do with this fraction now that I've got an exponent? So what I'm going to do next is I'm going to use the law of exponents, the rules of exponents. When you have a positive exponent in a fraction, if you move it to the other part of the fraction, it becomes negative. So I'm going to change this into 2 to the negative 3rd times 2 to the x equals 2 to the 5th. If you look at this carefully, all I've done is changed 1 over 2 to the positive 3rd to 2 to the negative 3rd by putting it on top. Okay. Now, what do I do next? Well, remember your laws of exponents. Let's say I have, what if I had 3 squared times 3 to the 5th? Your laws of exponents say you keep the same base, you add the powers. That would equal 3 to the 7th. So I'm going to keep the same base here, and I'm going to add the exponents. So I've got 2 to the negative 3 plus x on this side, and I've got 2 to the 5th on this side. So now I've converted, now I'm ready to go. I do have matching exponents, or matching bases. So now I'm going to set the exponents equal to each other. So I have negative 3 plus x, and I have 5. So negative 3 plus x equals 5. And then I'm going to solve it just like algebra. I'm going to add the 3 to both sides. So x equals 8. And that is your answer. Again, when you have a fraction, when you have an exponent in that fraction, if it's in the denominator or the numerator, if you move that term to the other part of the fraction, whether it be from denominator to numerator or numerator to denominator, the exponents, the sign of the exponent changes. So 1 over 2 to the positive 3rd is equal to 2 to the negative 3rd if you move it up top. Then we added the exponents because of the rule of exponents. When you have two different expressions multiplied together that have the same base, you add their exponents. So we added the negative 3 and the x. And then on this side, we converted the 32 to 2 to the 5th. Then we set up our equation and solve for x. So x is 8. If you want to check your answer, we can come back and we could do 1 over 8 times 2. And we have 8. 2 to the 8th equals 32. And let's check and see if that works. So I've got 1 over 8 times 2 to the 8th. Well, we know 2 to the 5th is 32. Okay. 2 to the 5th is 32. 2 to the 6th would be 64. 2 to the 7th would be 128, and 2 to the 8th would be 128 times 2, which would be 256. So I've got 1/8 of 256 equals 32. If I take 256 and I divide it by 8, I get 3. I bring down the 1 times, and I get 2. So 32 equals 32. Therefore, we have the correct answer. So that is how you solve exponential equations without logarithms.